Good day all. We are going to be looking at another example under Taylor series. Our question says find by Taylor series method the value of y at x equal to 0.1 and 0.2 to 5 place of decimal for the y over dx is equal to x squared y minus 1. Note that your initial value is y of 0 is equal to what? 1. Now, the three things that we need to know before we start solving Taylor series is first our function, our derivative function. We guys know it. We guys know our initial condition. That's the second thing to know. And the third is the value of the value of y, the corresponding value of y for each of the x's given to us. So for each of these x's, we are going to be finding the value of what? Y. But they have told us initially, that is our y of 0 is equal to 1. This means that our y is 1 when our x is what? 0. Our y is 1 when x is 0. Now they want us to find what our y is when x is 0.1 and also when x is what? 0.2. I want us to find these other two things. But the problem with this is that we don't know what our function is. If this thing was simply y is equal to x plus 1, we just simply substitute our value of x to get our y. But this time around, the function given to us is in a differential order. It's actually a derivative, the first derivative, if I'm being specific. So we can't just impute the value of our x's to get our corresponding y value. We are now making use of Taylor's series to get these corresponding values. Now, we have been given this. Okay, now we're also going to be doing the formula for Taylor series is for whatever corresponding y you're trying to find, y of any x that you're trying to find, you're going to be having that your initial y given to you, which is 1 in this case, your initial y, you're going to be adding it to x minus x0 multiplied by your first derivative and your x minus x0 around raised to power 2 multiplied by your second derivative all over 2 factorial. You notice here is 2, here is 2, here is 2 plus x minus over, here will be now 3, here will be 3, and here 3. Moving over to the next one, x minus x0 4 iv over 4 factorial. Then x minus x0 5 y 5 over what? 5 factorial. So as you can see, the reason why I said to stop at the fifth approximation is due to the fact they said the want 5 decimal place. So I don't know which of the values might get me to the 5 decimal place, but I'm sure that at the fifth decimal, at least I'm supposed to be close to the answer. But when we solve, we shall know all that. But to be at the safe side, I'm just stopping at the fifth approximation because of this statement here. Now, from the question, you can see that we need about 5 or 4 extra derivative. We're only giving one. The one we are giving here is just this. We don't know this, we don't know this, we don't know this, we don't know this. Now, the only derivative that was given to us was just this. So we need to find the, we don't also know its value. So we also have to substitute these our initial values into that, get our value, did for the rest of them. Now, draw a line here. So for our first derivative, which is the one given to us there, we have it to be what? X squared y minus 1. And we are told that our x is what? 0. This is statement I'm making use of. Y is 1 when x is 0. When x is 0, I'm going to be squaring it, multiplied by our 1 minus 1. At the end of the day, we have that our answer to be what? Minus 1. The second derivative, this is going to be an implicit derivative due to the fact that we are having our y in the function. So we're looking for a way to derive this. Now the idea behind our implicit derivation is just when you are having, let me say, x and y in a particular function, and they are multiplied to each other. The idea here is to differentiate first of all the whole of this function with respect to x, and then add it to the differentiation of the y with respect to x. So in this our case, or to be more specific, I can also say it has to do with that of the multiple rule in the product rule in differentiation, where you have that if you have something like u v, you're meant to differentiate these. You have your u, the differentiation of your u v plus your u. So this is the law I'm actually making use of, the product rule. So that's what I will be making use of here. So if I'm to differentiate our x squared y minus 1, differentiating this, our x is going to give us 2x. We'll keep our y. Now differentiating y with respect to x, we have plus, we're going to be having plus x squared y prime. Our y prime is also the something as well, dy dx. So we have differentiated y, and this is what we are having. Okay, now we just subtract it. The differentiation of your constant will definitely give us what? 0. So we'll be adding that. All this, then substituting our values, we have 2 times 0 times 1 plus 0 square times what? Our first derivative was what? Minus 1. When we solve this, we're definitely going to be having what? 0. We're definitely going to be having 0. Now we have gotten two values. We have gotten our y bar to be what? Minus 1. Our second derivative to be what? 0. Now moving over to the third one. Okay, so as we were saying, so when we differentiate this, our third differentiation, we're trying to get this guy now. It's not going to be, first we'll differentiate the x, and we're going to be having 2y. Then we add it. When we differentiate the what? Y. When we differentiate the y, we'll be having 2x y bar. Plus, we differentiate the x for this one. we are done with the first one. This is the outcome of the first one. Now the second one, differentiating our x, we're going to be having 2x y bar. And then for the y part, we're going to be having x square double bar. Now substitute. Okay, before we substitute, we can see some like terms here. This and this are the same in terms of their variables, so they are addable. When we add them together, we have 2y plus 4xy bar plus x square y double bar. Now when we substitute our values, we're going to be having 2 times 1 plus 4 times 0 times y bar was what? Minus 1 plus 0 square times our y double bar, which is what? 0. So definitely here is 0, here is 0, here is then going to be giving us what? 1. Sorry, 2. 2 times 1 is 2. So we are having that our triple derivative is what? 2. Is 2. Now, okay. Okay. So now let's move over to the fourth one. Sometimes like this, someone might be solving this close to you and you might slip off while they are solving it. But if you grab the idea, it's more like it's as easy as ABCD. It's quite easy. Implicit differentiation is not that hard. So long you know how to differentiate your x parts, the y is just simply adding another bar on top of it. That's just what we are doing so far. Now for this one, we want to differentiate the 2y parts. When we differentiate it, we're going to be having 2y bar. Now for us to move for the next one, which is this one had no x, that's why we're having only one answer. If it had x, we are having two answers. So but this one had x now, so we're going to be having two answers. So for the first one, we're going to be having 4y bar. We just differentiated the x and left everything constant, and we got this. Then we're going to be adding it to differentiating the y and leaving every other thing constant. We'll be having 4x y double bar. These two came from this one. Now to the third one, which is this, differentiating the x part, we're going to be having 2x y double bar. Then you add it to x square y triple bar. Now let us substitute. Okay, before we substitute, first this and this are the same, so we can add them up. Similar here. Same thing also goes for that one in front. So we are going to be having 6y bar plus 6x y bar plus x square y triple bar. Substituting our values, we're going to be having 6 multiplied by our y is what? Minus 1. We also add it to 6 times 0. Definitely everything here will be giving us 0. Everything here will be giving us 0. The same thing also goes for this one. Y bar, and we have 2 here. So when we are done, we have that our answer is what? Minus 6, which is minus 1 times 6. We have minus 6. So our fourth one is what? Minus 6. Now, okay, so for our fifth and the last one, differentiating this, you're going to be having 6y double bar plus differentiating the x part and keeping everything constant to be having 6y double bar. differentiating the y bar, keeping everything constant, will be having 6x triple bar. We add it to differentiating the x, keeping everything constant, we have 2x y bar. Then we add it to differentiating the y part, keeping everything constant, we have x square y 4 bar. Now this and this are common, are having the same values of or variables, so we can add them together, similar to this and this. So when we do that, we'll be having 12y prime plus, okay, 6 plus 2 is 8, so we'll be having 8xy triple prime plus x square y fourth prime. Substituting our values, will be having x, we having 12 multiplied by our y double prime, which is what? Our y double prime is what? 0. So definitely here is 0. 8 multiplied by 0, that's the value of our x from the beginning. And our y triple prime, which is what? 2. Definitely there will be 0. Here will be definitely 0. And our fourth, this is minus 6. So the whole of this will definitely give us what? 0. So permit me to write it up here. So we have that our fifth derivative is what? 0. So we have succeeded in getting each of the derivatives. So we are almost done with solving. Only what is left for us to do is to impute those values that we have gotten into our formula and then substitute our value of x, and we are good to go. So before we substitute our value of x, I would like to update our formula, since we have gotten what? This and this, and we can also write the values of all the things here. So I think the formula can be we can adjust the formula a bit. So when we do that, we know that our y already is what? 1. Still working with y of x. We don't want to substitute our x yet. Still working with y of x. So our y is what? 1. Okay. And we add it to our x, and we know that our y bar, which is this, our initial y, our initial x sum, which is this. This is also our initial y. Referring to the 0 there refers the first or initial, and what you choose to call it, the first x or the initial x given to you. So we know this to be what? 0. So anything minus 0 is definitely that thing. So we can just put this in brackets, and our y bar is what? Minus 1. We add this, the same thing goes here. So we're going to be having x square, and our y double bar is what? Multiplied by what? 0 all over 2. 2 factorial is also written as 2, or you can say 2 times 1, whatever you choose to write down. Now over here, the reason why we're not adding our x bar is due to our x bar is what? 0. So anything minus 0 is definitely that thing. That's why we're not including it. So our x can be given to us. We don't want to substitute it yet. We just want to adjust the formula. But this step is not actually necessary. You can actually just substitute everything and get for your x when it's 0.1, like we did in the last video. But I just want to kind of clinch my formula a bit, make it smaller. Now, for the sake of space, that's the way I'm doing this. Okay, now over to the next one. Substituting our values again, we're going to be having, inputting our values, we're going to be having, definitely here is 0, so this is going to be going out. This will be off, this will be off, this will be off, this will be off, this will be off. Okay, now this raised to power 3 multiplied by our y bar, which we said is what? 2. over what? 3 times 2 times 1. We add it to the next one, which is our x raised to power what? 4. Multiplied by what? Minus 6. All over 4 times 3 times 2 times 1. We then add it to our last one, which is our x raised to power 5 multiplied by what? 0. That's the value of our y raised to our yv, our fifth the derivative, which is 0 over 5 times 4 times 3 times 2 times 1. So we can now rewrite our formula to be like this. 1 minus times minus times x is going to be giving us what? Minus x. So definitely here is going to be what? Off. So we're having 0 multiply everything here is off. Same thing with this. This is also off. So we're going to be having for the next one plus x. Okay, we're going to be having 2x raised to power 3 raised to power 3 all over what? 6 plus, okay, so that's going to be what? Minus. We're having minus 6 here. So it's going to be minus 6 x raised to power 4 over, this is going to be giving us 24. So this is our what? The formula we're going to be working with. So permit me to clean this and write this over here. Okay, now we have gotten this, so we can now substitute our value of x. Now when our x is what? Is 0.1, our y is now going to be, you can choose to also say y of 0.1, whatever you choose to or say or write. So our y is now going to be 1 minus 0.1 plus 2 multiplied by 0.1 raised to power 3 over what? 6 minus 6 0.1 over what? 24. Now substituting our values, we're going to be having, I say substituting with our calculator, we can now easily get our answer. So I've got my final answer to be 0.999 something, but I'm going to be approximating to 5 decimal place. So I'm having my answer to be approximately 0.9031. So this is the approximate value of our y when x is what? 0.1. Now someone might be asking, is this formula actually the value, when we differentiate our dy dx, when we integrate our dy dx, are we actually going to be getting this to be our answer? The answer is no. The idea behind Taylor's series is to kind of craft a formula that will have the same properties like the one given to you. I tried to explain that in the first video. So when you differentiate, when you integrate this, you won't get this, or you won't get anything but these have small properties that this one also possess, but they are not the same in every ramification or every values. So this might work to a particular extent. It will look alike to a particular extent, like this one. So they are more like a look alike, but it is not perfectly the value of that of this when you integrate it. Okay, so with that out of the way, we can now find for that of x when it is what 0.2. So when while x is what 0.2, when x is 0.2, we have our answer to be our values or formula to be our edited formula to look like whatever you choose to call it. Okay, so we have 2 bracket 0.2 raised to power what 3 over 6 minus 6 0.14 minus what 24. When you approximate this, the approximate value will then be so I've got my approximate value to be 0.8027 approximately. So when our x is 0.1, approximately our y is 0.80227, and so on and so forth. So these two are our answer. So we have gotten the values of the value of our corresponding y value of each of the x's given to us, and that's the end of the whole Taylor series. So thank you for watching this video, and I hope it was helpful. At first I'm doing this for the sake of educating myself and both my audience. Thank you for the encouragement. Thank you for the positive feedback that I've received, but not in the comments, but in person. I pray that God will see us through all this struggle. Amen. Please subscribe to the channel if you haven't, like, and also drop down your comments. It can be more of encouragement to me and also to others, and we can also learn from your questions if you have any. So see you in the next video. Goodbye.